Alright, so this is part 2 of how to make the brushless DC fan motor tester. The only reason I'm making this video is because a few of you have asked. So this is the one that I showed you before. I just made another one. I just want to say you should not be doing this unless you are a licensed air conditioning mechanic or a licensed electrician. If you're not, you should not be doing this. This is a video designed for air conditioning mechanics. So if you are one of those people and you want to make it, this is the video for you. If you're not, I don't recommend making this. Anyway, that's the one I showed you before. I've just made the exact same thing again, so you can test fan motors out on the field. So I'll show you how to do that now. Okay, so now we are going to do like the actual wiring. So in the other video we made like the case, and we've added the transformer, the Vera board, the potentiometer, 2 LEDs. So now the first thing I'm going to do is add somewhere that I can plug power in. So I just got something like this that has a fuse. I bought that offline. You can get it from anywhere, any electronics store, J-Car, whatever. The reason why I bought this offline is because J-Car didn't have something like this. On another one of these I made one that had a fuse soldered into the board, but that was version 1. We're now up to version 3 for me. This is just a replica of version 2. Basically, I just thought if something like a fuse blows, I want to be able to change a fuse without opening this up. Someone made a comment on one of my videos saying it'd be cool if you put like a circuit breaker in here, which is another cool idea. So whatever you want to do, but I'm just putting this in. So I'm going to cut that in and put it in now. Alright, so once you've put that in, we're good to start doing the actual circuit. But that's step 1. Put somewhere for you to get power into this, and then we'll do the rest of it. So with this, if you turn it around, it has line, neutral, earth. So I've just joined them up. So power goes to line, obviously, goes to the fuse, goes through the fuse, and that will go to the board. So I'm going to put the wiring diagram up. Basically, the earth of that I've just soldered to the base of this. So if this metal casing ever gets live, it's earthed. So I'm just going to leave that for now, and I'm just going to do the board, and at the end I'll connect up my active and my neutral. So the first thing I'm going to do is make 2 bridge rectifiers. So I've just got 4 diodes for each rectifier. So I've got 4. That's the part number from I think they're from J-Car. That's the part number. So I've got 8 in total. So pack of 4, pack of 4. So I'm going to do this twice. Basically, I just like split them up and put it like this, and I'm just going to solder that. So let me get something to show you. Let's get it to focus. So with these diodes, you've got one side is just black and the other side is got like that grey strip. So if you put it like this and solder it, basically I'm going to put my line and my neutral on either side. So line there, neutral there, or vice versa, it doesn't matter. And then that will turn that into negative DC and that into positive DC. So it's line AC, neutral AC, or vice versa, doesn't matter which way. That will become a DC negative and a DC positive. So I'll solder that now on both of them, and then I'll put it in the board. Alright, so I've soldered them up. They're both exactly the same. And now I'm going to put them in the board. Alright, so I've just soldered them in, so it doesn't look neat, it doesn't have to look neat. It's not a printed circuit board, you just got to do it right. So focus more on doing it right so you don't damage anything. But one of these bridge rectifiers is for 240 volt power and the other one is for 12 volt power, both AC. So basically the red is our 240 in, goes to there, and neutral goes to there. So if I flip it over, that's what it looks like. So I don't know if you remember what I said on the other video, but I recommend getting Vera boards that just have rows of like copper. I've already done this neat. I just am doing this quickly to show you the video, but this is all I could find, so I've just made my own row. So that's just connecting the neutrals up. So basically for this, that is a AC 240 volt active, neutral, and that will be 12 volt AC active. So active neutral for 240, active neutral for 12 volt AC. So that means we're going to have a DC circuit and a DC circuit. Okay, so when power gets plugged in there, but for me, it goes straight into an active. Sorry, it goes straight into a fuse. It goes through the fuse, and from the fuse, it supplies 240 volt AC power to here. So AC power to that side of the bridge rectifier. The opposite side is the neutral. The neutral goes back to the neutral of the switch. Also from there, it sends 240 volt to this transformer and neutral back to the switch. So basically, I know it looks fully complex already. All that's happened is supplied power and neutral to a transformer, supplied power and neutral to this. This is the 12 volt AC voltage coming off the transformer. So 12 volt AC to that, 240 AC to that. It's 2 bridge rectifiers, 1 240, 1 12. It's not as like full on as it seems. So power in supplies 240 volts to a transformer, which then supplies 12 volts AC to that, and 240 volt to that. Alright, so this is ready to sort of test, but I've just done a couple of things which I'll explain. So I've put 2 capacitors in. So I did make one mistake before, which I have just corrected, and I'll explain it now, and then I'll explain the 2 capacitors. So currently we have 240 volts, like the mains power going in. Basically it supplies your AC 240 and your neutral 240 to one bridge rectifier. The other one, once it comes out of the transformer, it's 12 volts AC power and your 12 volt neutral or common, whatever you want to call it, to the 12 volt side. I did have the neutral for the 12 volt side and the neutral for the 240 volt side joined. I shouldn't have done that, so I've just changed it on the board. So these 2 bridge rectifiers are in no way joined. So the 12 volt side isn't part of like the high voltage side. The reason why I did that is because there's going to be 2 DC circuits, and the 2 DC negatives are will joiner, but not the AC side. So I have put between the positive and negative side of the 240 a 100 microfarad capacitor that goes up to 400 volts. So 400 volt, 100 microfarad, because that's going to be a 320 volt circuit. So a big capacitor, 100 microfarad. And for the 12 volt, I've put in a 470 microfarad, 25 volt. So yeah, the only thing you need to know about that is the strip on these capacitors, and there's one on this side, the gold strip. Whatever the strip is means it needs to go to the negative side of the DC circuit. If you put them the wrong way, it gets like gas build up and they literally will just explode. So the normal capacitors you use out in the field for HVAC, doesn't matter which way you have them, but these electrolytic capacitors, you need to have the strip on the negative 100%. So I'm going to plug this thing in now, and we'll have 240 volt. Basically I'll just test all the powers, and that's like the start of the circuit. So before I test it, actually I'm going to put in a varistor, which is just a variable resistor. So that just goes in between the active and the neutral. So if there's an influx in voltage, it'll just have a direct short and trip the fuse. But under normal conditions, it will have no continuity and it won't trip. That's just like a second protection method, I guess you'd call it. So I'm just going to solder that in now, and then we can test it. Alright, so this has got power on it now. So I'm going to put it on DC. So on the 12 volt bridge rectifier, it should be producing like 16 volts roughly on the DC side. And if you're doing this, just be careful. It's hard to do this when it's not fixed in position. So that is 16 volts. That's literally perfect. And the other one should be like around 320. It's hard to put pressure on it. It's 317, which is pretty good. That's totally fine. Alright, sweet. So basically what that is doing is like we've just generated a power supply for the like 320 volts DC for the fan motor, and that was 16 volts. But that's going to go into like a voltage regulator that's going to give it like smooth 15 volts, but we're going to do that now. But basically, yeah, we've got 320 volts DC and 16 volts DC, and that is just supplying the two separate power supplies that you need for modern inverter fan motors. So that is the start. Alright, so the next step is we need to solder one of these things, which I'll show you what that is. One of them. So that's called a voltage rectifier. So I'll put the thing up. I can't get it to focus, but yeah, I'll put the part number up. What that is. So I'm going to put a heat sink on that, because you really should. But if you don't have a heat sink, then don't worry, it's all good. It's totally fine. So that basically has 3 prongs out the bottom. And the middle prong, so just put that anywhere in the board. The middle one is your common. So I've just soldered in. That middle one gets soldered to the DC side of the bridge rectifier. And then daisy chain over to the DC side of that bridge rectifier. So basically the DC side of both of them I've just joined and then sent it over, so this one has a like a negative. And then on the, depending on which way you look at it, but that side of it, so that I call that the back of it, and the other side is the front of it. On that side, I run a cable, and that's going to go to my red LED, so I'm going to wire it differently this one. I want the red LED to be powered up at all times, so when you plug it in, you know it has power. And then that's the feedback. So I'm going to, I guess, just like go through this, but it's not like a step-by-step video. I'm going to give you the wiring diagram and you can do this yourself. I'm just sort of showing you me doing this. If you have any questions, definitely hit us up. Happy to help, but it's just too hard, like going through everything step by step. So the only reason I'm making this video is because people want to see it. So anyway, so basically I need to put another capacitor, so it's a 16 volt one, 470 microfarad, and that's going to go between one side of that voltage rectifier and the negative side. And you can see that on the wiring diagram. So I know it looks like there's just stuff going on everywhere, but I promise you when you start doing it, it'll seem really basic. So at the very start, we made the two bridge rectifiers. One just supplies 320 volts for the fan to spin. So I just like soldered a red cable out for that, and that's just going to be to plug into the fan. And the other low voltage bridge rectifier, that is supplying 12 volts. And all this thing is, so we just supply 12 volts to it, and it just gives us a steady 15 volts. And that's the control, like the logic side of the fan, so the PC board. So it looks like there's a lot going on. Once you start, like, I don't know, it's not that bad. It's literally like 3 different things. So that is just going to supply like 15 volts to this, and that's like a speed controller. So that's the orange. The reason why I've chosen these colors is it matches what the Daikin fan motor colors are. 15 volts. We're also going to put a cable out just for straight 15 volts to plug into the board. Alright, so on the voltage rectifier, these things can get hot, so I have just like taken these off PC boards that I've taken out like at work, so honestly old PC boards. You don't need to worry about doing this because honestly this isn't going to be on for long periods of time, only when you're testing, but they're designed to have a heat sink on it. So I'm going to put some paste on it, put that on it, just because I have it. If you don't have one, honestly, it doesn't matter. So I just went and got these from JCar. It's honestly not really what you need, but you just make your own plugs. I've just used these bits and like cut it, crimp it on, and then I've soldered it and put heatsink over it. So sorry, not heatsink, heat shrink, whatever you call it. Heat shrink. So cut it, put one of them on, solder it so it's a good connection, and then I've just put some heat shrink over it. That's what I've done. The reason why I've done that is I just want to be able to plug in any fan motor that I come across, instead of having like a plug on here just for Daikin or having a plug for all the brands. I guarantee you you'll come across something where the plug doesn't work, because even Daikin has more than one plug. So that's what I've done. But Alright, so it's ready to go. Just plugged it in. So the cables match up exactly for the fan, for Daikin fans. But I've just written the colours here. So when you come across a different brand, just read on the fan or wherever, it'll still be 5 cables. It'll be exactly the same, but theirs just might be different colours or whatever. So you just read what it is and match up. So we have the 320 volt supply, the negative, the 15 volt supply, and then just the speed controller, which is called VSP, and pulse generator, which I just call feedback. So when we turn it on now on this new one, if that turns on, just means that there's power in the circuit, and that's the feedback. So let's see if it works. It works. That's off. Speed it up. So, a quick backstory on this fan. This came out of a customer's fan. So she had a Daikin and it had a, can't remember what the fault was, but it was E something. It was basically meant it was an outdoor fan motor fault. So when you get that, it could be outdoor fan motor or the board. So what I did was I just took this out, because it takes 2 seconds to take it out of the unit. Took it with me, came home, made this, tested it. I'm like, alright, it's not that, that must mean it's the board. The board currently isn't in stock, so we're just waiting for it to come in stock, and then I'm going to go back and put it all back together for her. But now this stays in the van with me, so whenever I go to stuff like that, I can just test it on the spot. So this was just like made because of necessity, really. So I reckon it's definitely something that's worth having, but it also just makes you understand how these things even work.